This is a video on the binomial series. The question states, use the binomial series to find the Mclaurin series for f of x is equal to 1 over 1 plus x squared quantity cubed. So first let's recall what the binomial series formula is. And it says that 1 plus x quantity to the k power is equal to 1 plus kx plus k times k minus 1 over 2 factorial x squared plus k times k minus 1 times k minus 2 over 3 factorial x cubed plus k times k minus 1 times k minus 2 times k minus 3 over 4 factorial x to the fourth plus etc. and we get the idea. Our function is 1 over 1 plus x squared cubed. So I'm going to move the denominator up and use a negative exponent. And what I get is that my function is 1 plus x squared to the negative third power. And in this way, I can realize our k as negative 3. So now I just plug in. Everywhere I see a k, I can put in a negative 3. And you may wonder, this says 1 plus x, and we have 1 plus x squared. So everywhere I see an x, I'm going to put an x squared. So I do that, and I get that our function, 1 plus x squared to the negative third power, is 1 plus negative 3 x squared plus negative 3 times negative 3 minus 1 over 2 factorial x squared squared plus negative 3 times negative 3 minus 1 times negative 3 minus 2 over 3 factorial x squared cubed plus negative 3 times negative 3 minus 1 times negative 3 minus 2 times negative 3 minus 3 over 4 factorial x squared to the fourth plus etc. So I can simplify all these numbers. Notice that 1 plus negative 3x squared is just 1 minus 3x squared. We have negative 3 times negative 4 is 12 divided by 2 factorial is 6. And x squared squared is x to the fourth. We have negative 3 times negative 4 times negative 5 over 3 factorial turns out to be negative 10, and x squared cubed is x to the sixth. And negative 3 times negative 4 times negative 5 times negative 6 over 4 factorial times x squared to the fourth turns out to be 15x to the eighth power. Then plus dot dot dot. Now let's look for a pattern. You may or may not see this. First, hopefully you do see that we have a positive 1, then minus, plus, etc. So we do get an alternating series. The powers of x are all even numbers. And these numbers, 1, 3, 6, 10, 15, let's recognize these as follows. We can say that 1 is 1 times 2 over 2. 3 is 2 times 3 over 2. 6 is 3 times 4 over 2. 10 is 4 times 5 over 2. 15 is 5 times 6 over 2. So we see that each of these numbers is a number times the next divided by 2. And if you look at the powers, if you take the power and divide by 2 and add 1, that's the first number here. So 6 divided by 2 is 3, plus 1 is 4. So we can put this all together and write down our series as a summation from n equals 0 to infinity. Remember, it was an alternating series, so we get negative 1 to the nth power, n plus 1 times n plus 2 over 2, that's what these numbers were, x to the 2n. And I'm done with the problem.